All right. We are live, I do believe. That's interesting. I must have to change the privacy settings to be a little bit different if I want to go. Yeah, anyway, we are live. And it'll be a while before anyone gets on, I think. But what I'm going for with this stream is to test some of my new streaming equipment. I've already done so privately on Patreon, but I have not done it to a larger audience. And I want to make sure that everything works properly when I have more people on. And so this is my first ever public live stream, whereas I've done quite a few non-public streams for Patreon. Yeah, I am hoping with a new live streaming setup that I have here, I can switch cameras, do all sorts of stuff, and I just want to make sure that everything works well during a public stream before I actually take this to the main channel. Hopefully this weekend I will be ready for that. If you are online, let me know. Leave me a comment. I want to see... I want to know who I'm talking to here. Height Trend, good to see you. Yeah, so the goals for this stream: to test my streaming equipment, to see how I handle more people simultaneously in the comments, make sure that the comments come in for me well. And I have a more technical purpose also. I want to test some new PCM additives, phase change additives. I assume anyone who's subscribed to this channel already knows what PCM is. I want to test some new additives and hopefully put some prior art out there for these additives so that they are not patentable. I do not want some of the additives that I've been playing with and that I've been thinking over in my head for PCMs to get patented by somebody else. So by making a video testing these additives, it should disqualify them from being patented. All right. Yeah, first public live stream here. No script for this. I am trying to get some work done, actually, as we do this stream, as I said, testing these PCM additives, so it will not be especially polished. I will be doing a public stream on the main channel this weekend, I hope. And for that, I actually have bullet points and kind of a plan for the video, how that's going to go. That should be a Senko Hanabi Masterclass. I've done quite a few Senko Hanabi videos. It's been about 2 years since my last one. And I want to keep it going, and actually, because I'll be doing this live, digging into Senko Hanabi sparklers, I'll be able to get into some things that, for the sake of time in my normal videos on the subject, I have not been able to get into. And so it should be pretty interesting to be able to talk about Senko Hanabi live, actually roll the sparklers live and take some questions. At the moment, what I'm doing here is I am preparing some water to make into PCMs. Now, I don't want this water to be boiling. I have found that it actually works better, contrary to my previous PCM experiments. I found that it actually works better to have the water somewhere around 130 or 140 degrees Fahrenheit instead of near boiling as I did in the original PCM video. Welcome everybody. I'm still getting a handle on how to do live streams, so forgive me if I'm a little awkward on camera. Hope the audio's okay. I should probably have checked that before I started the stream, actually. Make sure that I can hear myself in this microphone. That mic is supposed to be significantly closer to my face as I'm speaking in order to pick up properly, but I'm trying to use it at more of a distance so that I can walk around a bit more, at least until the point where I decide to get a wireless lavalier microphone set up. All right, looks like we have about 12 people watching right now. That's pretty good. It will be a whole nother thing when I actually start streaming on the main channel. That'll be quite interesting to see how many people we get on and how quickly the comments come in. Live streaming might be the only circumstance where I'm not able to read all of the comments that come in on my videos. I do try to keep up with all the comments on my ordinary uploads, but while I'm trying to do something live, it might be a little hard to keep track, although I'm keeping track with you guys so far. So, the PCM experiment that I am working on today, in my PCM video on the main channel, we dug into personal cooling packs using sodium sulfate as the primary ingredient. And this is, of course, a phase change material like ice, except instead of melting at 0 degrees Celsius, it melts at like 18 degrees C, much closer to body temperature, but just cold enough to feel cold on the skin and take energy out of your body and cool you down without actually causing frostbite or something like having an actual ice pack pressed against your skin would do. One of the problems that I did not really talk much about in the main channel video is that a salt PCM, like a sodium sulfate PCM is, they tend to settle out after time. And after repeat freeze-thaw cycles, they can lose their effectiveness. And the main cause for this is the crystals in the PCM actually settling, falling to the bottom of the container, and then once the PCM melts again, they don't evenly distribute. This is not really an issue for the personal cooling packs that we talked about on the main channel, because in the use case of a personal cooling pack, you have it pressed up against your body, you're moving, you're doing activities, and just by the very nature of a personal cooling pack, you're moving it around very often. And so that settling issue of the crystals falling to the bottom of the container is not really a problem, because you're constantly agitating a personal cooling pack whenever you use it. It is, however, a problem when it comes to using PCMs for something like regulating the temperature of a building. A lot of people have talked to me about wanting to use PCMs in their greenhouse for various circumstances of regulating building temperature. And I did not emphasize in the main channel video how difficult of a challenge that is. I showed that, that's a possibility to use salt-based PCMs for building regulation, but the challenge is that these PCMs settle over time if they're not regularly agitated and dramatically lose effectiveness. So there's been a bunch of papers that have researched this topic, and some of the more promising things are gelling agents. So in an attempt to reduce this settling effect, we used xanthan gum in the main channel video. There's other additives that also work, like sodium polyacrylamide, I think it's called, the super absorbent stuff that's in like diapers and things. You can use that in a PCM to soak it into those super absorbent crystals, and you end up with the PCM being in a state where it can't settle out. And so you improve the effectiveness. It's not perfect. It still loses some of its effectiveness after repeated freeze-thaw cycles, but it's much better than as a if you had it in an ordinary non-gelled state. Let me. My heater's getting a little warm. I got to turn this off. So there has been some recent papers about solving this cycling issue with PCMs, and one in particular seems to have actually solved this issue entirely. Let me actually pull that up and show you a paper here, and you guys are getting a sneak preview of something that I may or may not talk about on the main channel. Let me pull this up here. So, here we go. So this is a paper here. Let me just double check if this is the correct paper. Yeah, so this paper is discussing a stabilization method for salt-based PCMs where they use a polysaccharide, which is the same category of chemical as xanthan gum, but they use a polysaccharide that has been modified to have sulfate groups. Now, we're using sodium sulfate as the actual PCM material, and so the sulfate groups that they've used to modify the polysaccharides that are gelling the PCM solution, having a similar type of chemical group bonded to that gelling agent seems to really improve the effectiveness of PCMs. In fact, they reported a 290% increase in the heat storage capacity of PCMs when using a sulfated gelling agent, which actually, if you remember from my PCM video, and if you caught the Patreon live stream where we actually tried to test the PCMs in a calorimeter, I found that the PCM performed better than ice, which it was not supposed to. Sodium sulfate PCMs are supposed to be a little bit worse than ice at storing heat, and so that was a really weird result. But this paper actually confirms that it's possible to actually increase the performance of PCMs. These are not the correct papers. Anyways, sorry, that's not the correct paper I have pulled up there. But one of these papers confirmed an actual increase in performance of PCMs, which makes my result not seem so unlikely. So that was a happy thing to discover. One of the things that I was thinking about in well, let me start over. So this paper discovered that they could improve the process, or they could improve the stability of their salt-based PCMs with this sulfated polysaccharide. This ingredient is called DSS, and it seems to be extremely effective. Almost the exact same performance is measured from the PCM after over 100 freeze-thaw cycles as when it was first made. So basically zero degradation with freeze-thaw cycles. So perfect, right? That's like exactly the ingredient we want for using a PCM in regulating the temperature of a building. The only issue, well, first of all, the people who put out this paper, or I'm assuming it's the people that put out this paper, did file a patent on using these sulfated polysaccharides as a stabilizing agent in their PCMs. And so that's not available for other commercial uses, unless they are the ones working on it. I mean, they discovered it. They deserve to patent their stuff that they discover and make a little profit on it. But that like limits what I can do as far as using this sort of mechanism to stabilize these PCMs. And there's another problem, and that is that DSS, this chemical that they're using to stabilize their PCM, DSS is a chemical which has its most common use up to this point has been used in laboratory studies. They give it to laboratory mice to induce irritable bowel syndrome. Like, this is a chemical, actually worse than that, like ulcerative colitis. Like it makes ulcers in your intestinal tract if you ingest this chemical, and those can become permanent, a chronic illness if you ingest enough of it over a couple weeks. So not exactly the chemical I want lining the walls of my house. I mean, I guess if you have a mouse infestation, it wouldn't be the worst to, get back at them by giving them all IBS. But yeah, not exactly the ideal ingredient that I want in like my personal cooling packs, or if I were to make like a pillow liner, like a cooling pillow liner out of a PCM, I would not want to have a chemical in there that if ingested would give me IBS. Yeah. So there's some downsides to this ingredient. It's also like $250 for 100 grams, like a little salt shaker size container. And if it were made at scale, that price would go down. There's just a whole lot of issues why I don't want to use this particular chemical. But there was another paper that came out analyzing the results of this first paper, and they determined that it was in particular, they think that it was the sulfate groups that they added to the polysaccharide gelling agent, which caused the PCM to work so much better. They think that because the gelling agent had these sulfate groups, which the actual PCM also has, that they were able to transfer water between the two chemicals very effectively. So when the PCM froze, it gives up a little bit of its water. That water goes into the gelling agent, and the gelling agent kind of stays bonded together with the chemical in the PCM, so that when it melts again, the water can easily like bridge the gap back over, and you don't get any settling and you don't get any phase separation that remains permanent. So I had an idea to use a different sulfated compound instead of these sulfated polysaccharides, which have expense issues, patent issues, and health issues. I decided to get a big old bag of SLS, sodium lauryl sulfate. This is the main ingredient in dish soap. I got a gigantic bag because I really want to try this in bubble mixes. This is like the key ingredient in dish soap that does all of the foaming and all of the cleaning action, and everything else is just kind of additives to modify this SLS in some way. This is like the most reliable way, I think, or it will be, I think, the most reliable way to make bubble mixtures because the formula for this never changes. Whereas commercial bubble mixtures, one year to the next, they might add different additives. I actually encountered one of the best known bubble making soaps was like Dawn Manual Pot and Pan years ago. That was a detergent that worked really well for making giant bubbles. They actually added an anti-foaming additive to that soap now. And so all the recipes that used to work really well are like really sabotaged by this new ingredient. And it's now one of the worst soaps that you can use for making giant bubbles. So anyway, the SLS should be a much more reliable way to consistently make my giant bubble mixtures. Anyway, back to PCM. So the reason that I got this for the purpose of making PCMs is this is a sulfated ingredient. It's a very polar molecule. It has a sulfate group on one end, which is very electrically charged, and it can grab onto things like oils and grease. And that's, obviously the reason that soap works. And this is basically, it's got the same group on it, the same chemical group that makes the sulfated polysaccharides work in the paper that I was looking at. So I'm wondering if SLS as an additive could work just as well to increase the cycle stability of PCMs. So that's what we're going to try here. And fortunately, there's no patents on this. I really want to, I really wanted to make this video in particular public so that this experiment, whatever the results are, would put the recipe out there. We'd get some prior art for patents and things out in the public so that other people can't patent this if it ends up working. And in that way, hopefully we'll be able to put this to some use and keep it as a good DIY solution. So I've added, how much did I add? 1,200 milliliters of water to this pot. Let me bring you guys down here, get my desk cleaned up a little bit. Let me bring you over to... All right, so I have a whole bunch of notes here. I'm not totally sure I want to broadcast these notes to the public, but I guess I will, as if anyone could interpret my writing anyways, and my note-taking. I've been making 300 milliliter batches of my PCM mixture. I've been using 300 milliliters of water to make about enough to fill a Ziploc bag, like a quart-sized Ziploc bag. I just put enough water into my pot for a 4 times batch, because I'm going to make a single batch divided into several different samples and add different additives to test the PCMs against each other and see if the additives make a positive difference. I'm not going to try to optimize anything today. I'm just going to try to kind of do just a rough test of you know, the base mixture of the PCM, and then see if the additives make any difference for the positive or the negative. So I will start with 300 milliliters of water, which I have four times that in the pot, and then I'm going to be using these ingredients here. So 110 grams of sodium sulfate per 300 milliliters of water, and then 10 grams of table salt, and 1.5 grams of xanthan. All of this is times 4 for a 4x batch. All right, let's bring you guys back over here. All right, let me read a little bit of your comments, see how you all are doing. Cursed Void, yeah, I did figure out my camera setup for the Senko Hanabi stream. I think that will go well. It'll be basically this setup, except I'll be sitting at the desk, and I think I figured out how to get a good angle from my second camera here. I think I figured out how to get a good angle on the Senko Hanabi, and then the main issue was trying to get the audio so that I could pick up the sparklers. And I have my fume extractor up here, which I needed to get set up, and I needed to figure out a way the other day to make my fume extractor much quieter so that you could still hear the sparklers over the noise of the fan. Because yeah, the sparklers are quite quiet, and I want to be able to hear them in the live stream. Let's see what else is going on here. Totally normal. Hey, I just realized I realized after you dropped in on the last live stream that you were the guy that did the live stream making the PCM packs. That was so cool of you to do. Thanks for doing that. I really appreciate when people make their own videos, sharing their experience with the projects that I put together and post online. I feel like that used to happen a lot more on YouTube than it does today. The culture of YouTube has changed, where it's less, feels like less audience involvement in DIY projects on YouTube. But For those of you that don't know, I have a video response playlist on my channel. So if you replicate any of my projects, I prefer you do the ones. I prefer you don't replicate the ones where I ask people not to replicate them if there's something dangerous. But if you do any of my projects, take a video and email it to me at nighthawkvideoresponse@gmail.com. And that's what that email address originally started for people to send me YouTube links of their recreations of my projects so that I could put them in a playlist and feature them on my channel homepage. Like 15 years ago, YouTube used to have a feature called video responses where you could actually post a video to YouTube and then like reply to another person's video almost like a comment. I guess you can do the same on TikTok now where you can reply to someone's video with a video, and that I really missed that feature. It really made YouTube feel like more of a community when you could like visually reply to someone, especially in the world of DIY stuff on YouTube. Yeah, it was really cool to put out a video about how to do something and then get a bunch of videos back of people doing it. Yeah, the PCM packs though, totally normal. I'm so glad you made those, and I'm glad they're working out for you. Yeah, like I said, they work really well as personal cooling packs. That's like the perfect use case for them because of the agitation in everyday use. That prevents the main issue that this type of phase change material has, which is settling. If you're continuously moving them around while you use them, they're ideal, and they really, really work awesome. I've taken sandwich bag size PCM packs and put them into my pillow at night. I did that most of the summer long for both my wife and myself, and it really they are really awesome. Yeah, but the downside is if you're a very heavy sleeper, well, we'll talk about this later. There are some issues with using these PCMs as a pillow liner in their current state because of crystallization and other issues that can cause them to not quite work as you would hope, as well as you hope they would. Patrick Keegan asks, would I consider using an LLM to take some slope off the PCM research learning curve? Large language model. For some reason I read that as MLM, and I'm like, you want me to start an MLM? No. Would I consider using a large language model like ChatGPT to take some slope off the PCM research learning curve? Patrick, yeah, I do occasionally use ChatGPT or other AI to when I'm looking for very niche information on these things. Sometimes I'll pull up results. AI is really useful for finding really niche information. And then once you actually get the result from the AI, all you have to do is you have to be sure to check whatever sources they're using to find out if what they told you is, BS or not. But yeah, I have found a lot of really useful information thanks to AI as a search tool. I was just actually looking for a new search engine to use besides Google earlier today because Google has gotten it's gotten really bad. I don't know if you guys have noticed, but when you do a Google search for something, it's a little better if you're searching for scientific stuff because there aren't as many people advertising in that category. If I'm looking up research papers or something, I'll get good results. But if you look up anything that has a market to it, you'll end up with 10 ads and maybe 1 or 2 actual search results on the entire front page. And then it goes into videos and stuff right away. And it's just you do not get the results that you really need. Cursed Void asks if I could put in PEO. Would PEO be good for preventing settling in PCMs? The answer to that is no. Because PEO is decomposed by many different salts, and it is especially decomposed by sulfates. So if you add PEO into a sodium sulfate solution, it will disintegrate. It will no longer be long-chain lubricant. Yeah, that's actually, if you get PEO on your hands and it's really hard to wash off, The way to get rid of it is to put some table salt on your hands, and the table salt decomposes the PEO, and you end up with clean hands. All right. Now I am having some trouble some trouble keeping up with the comments. Okay, I'm going to get back to it here. Back to the process. Let's see what temperature our water is at. Too warm. I've been sitting here talking and not really paying attention to what I'm doing. It doesn't really matter if I go a little too warm. It's about 205 degrees Fahrenheit. That's, I don't know, 98 degrees Celsius. Something like that. I am going to add this into my mixing bowl. This is not the way to move boiling hot water around. I keep meaning to do a video about... I've had a video idea on my mind for years, it seems like, about... maybe I'll do a live stream on this. The difference between apparent danger and real danger. I find that the things that people think are dangerous, especially when it comes to watching DIY and science videos on YouTube, the things people think are dangerous are not the things that are really dangerous. And the things that are really dangerous are often they're often not obvious. Like moving a pot full of boiling water across the desk and pouring it like this, that's actually dangerous. You know, if I bumped my elbow on something on the way and the pot came this way and spilled out on the table, and you know, the water would run this way and burn my entire lower half. I have injured myself. I've never injured myself making one of my videos and actually doing the dangerous thing in that video. It's always been like slipping with a utility knife or something like that. Like working when you're too tired with something sharp. I burned myself once, actually kind of badly. I have a wood stove behind this curtain here. I burnt myself really badly one time taking a snowball in the middle of winter, and I had my wood stove screaming hot, and I just like took the snowball and dropped it on top. And it instantly turned into superheated steam and burnt the skin all the way up my forearm. Like, you burn yourself doing weird stuff that does not seem like it would be dangerous. You injure yourself doing that, like really mundane stuff. Whereas the stuff that seems dangerous is really often the stuff that you know it's like it seems dangerous, and so you're being really careful as you do it. It's the stuff that you're not being careful while you do it. That's what gets you. Okay, let's see. All right, so let's measure out our ingredients here. This water really needs to cool down now. Probably a little bit of it has come off as steam. I don't need to really worry about losing that small quantity of water, I don't think, but because some of it has come off as steam, I might be able to get away with adding a little bit back and cooling it down. What did I do with my scale? You guys see my scale somewhere? I had it here. I don't know what I did with my scale, guys. Let me walk over here for a minute and see if I left it over here. Yeah, I did. I was getting all the stuff ready for this stream earlier, and I saw the scale sitting on the shelf, and I was like, ah, there it is. And looking at it and saying there it is not the same thing as bringing it over to where you need it, it turns out. All right, I need 110 grams per batch size. Yeah, 110. So I need 440 grams of sodium sulfate in total. I believe this scale is good up to 500 grams. Let's bring you guys over here and you can watch me Watch me weigh stuff out. All right. Hey, thanks everyone for jumping onto the stream today. I know I didn't give any warning. Probably on, so the stream that I'll be doing on the main channel will probably be on Saturday. And I imagine I'll do it around noon Eastern time. I don't think I'm going to give anyone any warning for that either on the main channel. I think I'm just going to jump on live because, well, I don't want to pressure myself into jumping on at a very particular time for my first live stream. I want to make sure I need 440, don't I? It's a little bit heavier on the sodium sulfate. I realized that sodium sulfate dissolves a little bit better if it's when the water temperature is actually lower. Normally soluble, the warmer the water. Let me make sure we're... All right, are you guys... I'm hoping that... back. Oh, no.